Hi everyone, this is the first video on parabola. Here we are going to review the definition and the standard equations of parabola. Let's first take a look at the definition of parabola. A parabola is nothing but the locus of a moving point that moves on a plane in such a way that its distance from a fixed point is equal to its distance from a fixed line. The fixed point is called the focus and the fixed line is called the directrix, and in this case the eccentricity will be equal to 1. In the previous video, we have reviewed various conic sections. Parabola is one of them, and there we have reviewed the definition of the various conic sections, and the eccentricity is actually 1 for parabola. That's the definition we have reviewed in the previous video. I have shared the link in the description. Feel free to watch that video. Next, we are going to draw the diagram and we'll see how to derive the equation of parabola. Let's suppose this is the fixed point. It's actually the focus, and let's assume that its coordinates are alpha comma beta. And let's suppose this is the fixed line, which is actually called the directrix, and let's assume that its equation is Lx plus My plus n equals 0. And let's suppose this is our moving point P, whose coordinates are h comma k. Later on we'll substitute h by x and k by y to make it a general equation, but for now let's begin with h comma k as the coordinates of the moving point P. Next I'm going to join P and S, and then I'm going to drop a perpendicular from P onto the directrix. So PM would be the distance of the moving point from the directrix, and PS is the distance of the moving point from the fixed point S. So according to the definition, PS is equal to PM for parabola. And now I'm going to use the distance formula to express the distance PS. It should look like this. And then I'm going to use the formula for the distance of a straight line from a point. So the PM distance can be expressed like this. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. Next, I am going to draw a line through the point S, which will be perpendicular to the directrix, that will be the axis. And then I am going to draw the parabola. It could look like this. So this is the general equation of a parabola when we have been provided with the coordinates of the fixed point focus and the equation of the fixed line, the directrix. Next, we are going to see the standard version of a parabola when the vertex would be at the origin and the axis would be coincident with one of the coordinate axes. First, we are going to review the standard parabola whose vertex would be at the origin and the axis will be along the x-axis. Let's suppose we have the coordinate axis like this. I have it in the blue color. And let's suppose the fixed point, the focus, is located on the x-axis whose coordinates are a comma 0. That means it is a unit to the right hand side of the origin along the x-axis, of course, and that is actually the axis of the parabola. The standard parabola that we are going to review now, its axis is same as the x-axis. And then let's suppose this is the directrix which will be perpendicular to the axis. In this case the vertex would be at the origin. That means the distance of the vertex from focus will be same as the distance of the vertex from the directrix, because the vertex is also a point on the parabola. So the distance of vertex from the focus and from the directrix should be equal. So in this case, if the coordinates of S are a comma 0, then how far away is the directrix from the origin? Well, it will be exactly a unit to the left. So what would be the equation of the directrix? Well, it will be x equals negative a. That means the equation will be x plus a equals 0. So now we have the focus, we have the directrix, and we know the vertex is at the origin. And let's suppose the moving point is right here. I have taken h comma k as the coordinates of the moving point P. So let me join P and S, and then let me drop a perpendicular from P onto the directrix, and then let me draw the parabola. The parabola can be something like this. From the general equation of the parabola, if you compare alpha and beta with the coordinates of the given focus here, so alpha will be equal to a and beta will be equal to 0. And also let's look at the values of L, M and N in the equation of the directrix. In case of this standard parabola, the equation of the directrix is x plus a equals 0. That means the coefficient of x is equal to 1. Coefficient of y would be equal to 0 because there is no y term, and the constant term is positive a. So now we know the values of alpha, beta, L, M and N. So let's plug in those values in the general equation. We can write the equation like this. All I have done is I have used that general equation which you see at the very top, and I have plugged in the values of alpha, beta, L, M and N. Now let's simplify the right hand side a little bit. Our equation would look like this. And then let's take a square on both sides. Our equation could look like this. and then let's expand all of the whole squares. Our equation would look like this. And then you see we have some terms on both sides of the equal sign that would cancel out each other. And then we are going to be left with something like this. And if we replace h with x and k with y, then we can write it like this. Y squared equals 4ax, and that is the equation of this standard parabola. And this is also called standard equation of parabola. In fact, it is the equation of a standard parabola. Now, why do we call it a standard parabola? Well, because its vertex is located at the origin and its axis is along one of the coordinate axes. So, this parabola is called standard parabola. And we have the equation of this parabola. And there are three other flavors of this parabola which we will review later in this video. This particular parabola is also called right-handed parabola because it opens on the right-hand side of the origin. So, it is called the right-handed parabola. Now, let's derive a few attributes of this parabola. The first attribute would be the focus. We have already assumed that the coordinates of the focus are a, 0. Next, let's note down the equation of the directrix. We have already determined that it is x plus a equals 0. And next, let's talk about the vertex. Well, we know the vertex goes through the origin. So, the coordinates of the vertex would be 0, 0. And then, let's note down the equation of the axis. The axis of this parabola is actually the x-axis, whose equation would be y equals 0. Next, let's calculate the length of the lattice rectum. First, let me draw the lattice rectum. Let's suppose this red dotted line LR is the lattice rectum. It is nothing but a chord passing through the focus and perpendicular to the axis. That is called a lattice rectum. Let me also drop a perpendicular from R onto the directrix. Since the axis is the axis of symmetry for a curve like parabola, we can say that LS will be equal to SR. These two distances will be equal, and that will also be equal to the length of RQ, because you know the distance of the point R on the parabola from the focus will be equal to its distance from the directrix. So we can say LS is equal to SR, which is also equal to RQ, and that will be same as SG or SZ. And that can be written as SA plus AG or AZ, because if you assume A to be a point on the parabola, its distance from the focus will be same as its distance from the directrix. So then we can write it as A plus A, because we know the distance of the focus from the vertex is actually A unit. So the distance of the vertex from the directrix will also be A unit. And since we are calculating just the length, we are not going to worry about the signs here. So we can say LS will be equal to A plus A, and that will be equal to 2 times A. So if LS is 2 times A, SR will also be 2 times A. Therefore, what would be the total length of LR? Well, that will be 2 times of 2A, and that will be equal to 4 times A. So this is the length of the lattice rectum for this particular standard parabola. Now let's also think about the equation of the lattice rectum. Well, since this line is perpendicular to the x-axis and it passes through the focus, so x is always equal to a for any points on this particular line. That means its equation can be written as x equals a, or we can say x minus a equals 0, and that will be the equation of the lattice rectum. Let's also quickly figure out what would be the coordinates of the end points of the lattice rectum. Well, if you think about it, LS is actually perpendicular on x-axis, and we have just calculated the length of LS, which was 2 times a. So the coordinates of L would be a, 2 times a, and similarly the coordinates of R would be a, negative 2 times a. Next, we are going to see how to calculate the focal distance, I mean the distance of the moving point P from the focus, the distance PS. And if you think about it, PS is equal to PM as per the definition of parabola. And then if you look at PM, we can say PM is equal to PB plus BM. And then what is PB? Well, PB is same as the x coordinate of P, which is H. And then what is BM? Well, that is the distance of the vertex from the directrix, that would be A unit in this case. So this PM distance can be written as H plus A. And finally, if we replace H by X, then we can say this is equal to X plus A. So the focal distance turns out to be X plus A if the coordinates of the moving point P are X, Y. If the coordinates of the moving point are taken as H, K, then the focal distance will be H plus A for this particular standard parabola, which is the right-handed parabola. So we have completed the review of the right-handed parabola, which is one of the standard parabolas, and we are now going to review the 3 other forms. Next, let's review the standard parabola which passes through the origin but opens up to the left hand side of the origin. That parabola could look something like this. And here let's quickly review the coordinates of the focus, which should be negative a, 0, because in this case s is to the left of the origin. So a being a positive number, the coordinates of the focus would be negative a, 0 because it lies on the x-axis. And let's assume the coordinates of the moving point P are h, k. And let's quickly review the equation of the directrix, because the directrix is a unit away from the origin, and that particular position will give us x equals a. So its equation can be written as x minus a equals 0. Here again let's quickly make a note of the values of alpha, beta, L, M and N. Alpha, beta are the coordinates of the focus. So in this case alpha is equal to negative a and beta is equal to 0. And then let's note down the values of L, M and N, which are the coefficients and the constant term from the equation of the directrix. L will be equal to positive 1, that's the coefficient of the x term. M will be equal to 0 because there is no y term. M in fact is the coefficient of the y term, but in this case there is no y term in the equation of the directrix. N will be equal to negative a, which is the constant term in the equation there. Now let's use the general equation of parabola and plug in these values. So the general equation of the parabola could look like this. All I have done is I have plugged in the values of alpha, beta, L, M and N. Now let's simplify the right hand side a little bit. The equation would look like this, and then let's take a square on both sides. Our equation should look like this, and then let's expand all the whole squares. Our equation should look like this, and then you see we have some common terms on both sides of the equal sign which will cancel out each other. Here's the first pair that should cancel out each other, and here's the second pair that should cancel out each other. And then let's reorganize the terms a little bit. Let's keep k squared on the left hand side and bring everything else to the right hand side. So our equation can be written like this. And then let's replace h with x and k with y to make it a general equation. So our equation can be written like this. And this is the equation of this standard parabola, which is the left-handed parabola. The equation of the left-handed parabola is y squared equals negative 4ax. Next, we are going to note down the values of the different attributes like we did before. Coordinates of the focus, obviously negative a, 0. Equation of the directrix, x minus a equals 0. Vertex at the origin, so coordinates of the vertex should be 0, 0. Equation of the axis. In this case the equation is also x-axis, so the equation of the axis should be y equals 0. And then let's calculate the length of the lattice rectum. In this case also the lattice rectum length would be 4 times a. It will be exactly same as the length of the lattice rectum for the right-handed standard parabola. You can use the same technique to calculate the length. And because we are talking about the length, the sign is immaterial. We just have to concentrate on the length, just the length, I mean the absolute value here. And a is a positive number anyways. So 4 times a will be a positive number, and that is good enough for the calculation of the length of lattice rectum. And then what would be the equation of the lattice rectum? Well, the lattice rectum passes through the point negative a, 0, and it's a line perpendicular to the x-axis. I mean it is parallel to the y-axis. So its equation would be x equals negative a, which can be written as x plus a equals 0. And then let's quickly note down the coordinates of the end points of the lattice rectum. I mean the coordinates of L and R. I hope it makes sense. Because the x coordinate of L would be negative a, it will be same as the x coordinate of the focus, and the y coordinate would be 2 times a, because the length of LS is 2 times a. So the coordinates of L should be negative a, 2 times a, and similarly the coordinates of R should be negative a, negative 2 times a. Because R is below the x-axis, so the y coordinate of R would be a negative value. And then let's calculate the focal distance. I have noted it as absolute value of h plus a. A is always taken as a positive number, but in this case h will be a negative number because it is on the left hand side of the origin. So we have to be careful when we are using the value of h. In this case we have to take the absolute value of h. Now if the coordinates of the point P are taken as x, y, then x will obviously be a negative number. So when calculating the focal distance, we have to do it like this. We have to take it as negative x plus a, which can be written as a minus x. So we just have to be mindful when you are calculating length or distance like this. We have to kind of keep the picture in our mind, and then when we are using the value of h, we just have to be mindful about the sign that when calculating the focal distance, we have to take the absolute value of h. So this is the second flavor of the standard parabola. Next, we are going to review the third flavor of the standard parabola. And we are going to take a look at the upward parabola first. A parabola that will pass through the origin, but it will open upwards. So let's take a look. Here I have a picture of the upward parabola. The focus is located on the y-axis, and in this case the directrix would be parallel to the x-axis, and the axis of the parabola is the y-axis itself. The location of the focus is at 0, a. A is the distance of focus from the vertex, of course, and a is a positive number. And what would be the equation of the directrix? Well, if you think about it, the directrix is actually parallel to x-axis, but it is a unit below the x-axis. So its equation would be y equals negative a, and we can write it as y plus a equals 0. Next, I am going to note down the values of alpha and beta. They represent the coordinates of the focus. So in this case, alpha is 0 and beta is equal to a. And then let's also note down the values of L, M and N from the equation of the directrix. Their values would be like this. Here we do not have an x term, so L is equal to 0. We have a y term, so M is equal to positive 1, and the constant term is also positive a, so N is equal to a. And then I am going to do the same thing. I am going to plug in these values in the general equation of parabola, and then I am going to simplify this in the exact same way. So let me write down the steps here, and ultimately we get h squared equals 4ak. Now let's replace h with x and k with a y. So the equation can be written like this: x squared equals 4ay, and that is the equation of this particular standard parabola, which is also called the upward parabola. Here again, let's note down the values of the various attributes. Focus is located at 0, a. The equation of the directrix is y plus a equals 0. Vertex is at the origin 0, 0. Equation of the axis is same as the equation of the y-axis, which is x equals 0. Length of lattice rectum is also 4 times a, and the equation of the lattice rectum will be y equals a, that means y minus a equals 0, and the coordinates of the end points of the lattice rectum would be like this. And finally, let's talk about the focal distance. The focal distance will be the distance ps, which is same as the distance pm, and if you think about pm, it is actually in two parts. The lower part will be a unit and the upper part will be the y coordinate of the point P. So it can be written as k plus a. In this case, k will be a positive number because P lies in the second quadrant. So we can safely use the y coordinate of P, and the focal distance will be k plus a. And we can also write it as y plus a if we consider P's coordinates to be x, y. Now let's take a look at the fourth flavor, which is the downward parabola. I have the diagram ready. Focus is located at 0, negative a. The parabola passes through the origin, so the vertex is at the origin and the axis is the y-axis. The equation of the directrix would be y equals a, and we can write it as y minus a equals 0. Next, I am going to note down the values of alpha, beta, L, M and N. Their values would be like this. Alpha represents the x coordinate of the focus, beta is the y coordinate of the focus, and then L is the coefficient of the x term in the equation of the directrix, and M is the coefficient of the y term, and N is the constant term. So if you carefully look at the equation of the directrix, we have L equals 0 because there is no x term, and M is equal to 1 because the y term is a positive term, and then N is equal to negative a because that's the constant term there. And then I'm going to do the same thing. I'm going to plug in these values in the general equation of parabola. The equation looks like this, and then let's simplify the right hand side. Our equation would look like this, and then I'm going to note down the same steps as we did in the three other examples. Finally, we get h squared equals negative 4 times ak, and if we replace h with an x and k with a y, we can write the equation like this: x squared equals negative 4ay. And that is the equation of this standard parabola, which is the downward parabola. Here again, let's note down the values of the various attributes. Focus is at 0, negative a. Equation of the directrix would be y minus a equals 0. Vertex would be at 0, 0, which is the origin. Axis of the parabola would be the y-axis, whose equation would be x equals 0. Length of lattice rectum will be 4 times a. In fact, the length of lattice rectum is always 4 times a for each of these standard parabolas. And what would be the equation of the lattice rectum? Well, in this case, the lattice rectum is parallel to the x-axis. It passes through 0, negative a. So in this case, for any point on the lattice rectum, it will be y equals negative a. That means its equation can be written as y plus a equals 0. And then let's see the coordinates of the end points of the lattice rectum. They will be like this. And then let's review the focal distance. In this case, the focal distance can be written as a plus the positive value of k. Because if you think about it, k is actually a negative number since that's the y coordinate of the point P which lies in the third quadrant. So its y coordinate would be a negative number. So we have to take the absolute value of k plus a. A is the distance of the vertex from the directrix. And if we want to replace k with a y, then we have to take negative y plus a, which can be written as a minus y. So the focal distance would be a minus y if we consider x, y to be the coordinates of the moving point P. Let me note down the equations of all of these 4 standard parabolas again. This brings us to the end of this video. I hope everything made sense. Thank you for watching. See you in the next video.